Okay, good afternoon, everyone. Thank you very much for the introduction. I'm going to talk about a very exciting project, Immersive Virtual Colonoscopy. Virtual colonoscopy is a project we have been working on for the last 2 decades, and we already saved 30,000 lives. And I would challenge everyone in the audience to come back after 20 years and say, I saved 30,000 lives. In any event, this is a non-invasive alternative to optical colonoscopy, which is more accurate. The patient love it because it's very comfortable. It's also inexpensive, and what's more important, it's give you a full exam of the surface, unlike conventional colonoscopy. It provides basically a CT scan of the abdomen. We generate a 3D model of the colon, and then the radiologist basically playing a video game inside the colon. And they can do measurement, they have a light source, can leave bookmarks, can look at the 2D slices like you can see on the screen. This is an example of a user interface. So the 2D slices are on the screen. That's the endoluminal view, the main view. This is kind of an overview. You can think of it as this is the particular model of the 3D colon. So you can think of it as the model of the colon, and a few other tools around it. The only problem, this is really a desktop, and there are a lot of issues with that. And what we did in recent years, we took this desktop application and we ported it to our 5-surface cave. And then this project that I'm presenting today is the immersive virtual colonoscopy in a head-mounted display. There were a couple of motivations for that. Some of them are not very surprising. Some of them are surprising. The VR, it helps to understand the shapes inside the colon, specifically when we're looking for polyps, which are kind of bumps on the surface of the inside of the colon. And it allows us also to merge this navigation and display space, which is very, very helpful in improving the spatial awareness of the doctors. What was surprising is the doctor said that this head-mounted display allowed them to have a mobile reading room. They don't like to sit for 8 hours a day. They like to move around. So they were standing or walking in the reading room. But indirectly, what they get is a controlled ambient light, which is extremely important because it reduces the fatigue. It gives them a constant lighting situation that eventually improves also their results. It also gives them a wider field of view, a wider field of regard, which they like very much, and also reduces the repetitive stress. They're using a mouse for 8 hours a day. They don't really like that. So this is, we were very surprised by that part of, and we got a lot of feedback from the doctors I mentioned later on. The challenges we had with this immersive system were both in the interaction and the rendering. In the interaction, we developed a navigation strategy, measurement, flashlight, bookmarks, and slice view. And we were using tangible interfaces like a wand controller. And we tried to stay within the universal interaction paradigms. In the rendering, we had to accelerate it substantially, and we used mesh-assisted volume rendering, as well as hybrid mesh volume illumination to get this really in real time. Without real time, you can't really get this to work. So the navigation, here is the way we navigate inside the colon. This is one eye, but so we move forward, but when we change our view or change the wand, the system automatically slows down until if you turn 90 degrees from your direction of movement, it actually stops. So it also, when you interact with the surface, it stopped moving. And this is done automatically, and we have basically tried it in several other applications before. It works beautifully. In terms of measurement, we use the 6 degree of freedom wand to place these widgets, and we create the movement. We have a tool that allows us to use them to measure the distance between them, and you can use it at any time. It's not a separate mode that you have to switch to, so it reduces switching. And the feedback that you get is both a haptic feedback in the wand and the widget that you place or select is highlighted, which works very, very nicely. Also, they react to our light source, which give us a sense of distance from them. We use different colors for diverging colors for 2 measurements or 3 or more than 2 measurements that 2 or more measurements that are in the same neighborhood, and we use the text to scale it depending on the distance from the viewer. The flashlight is basically a virtual magic lantern, and we used again the 6 degrees of freedom wand as a flashlight, and therefore you have a good control over both the direction and the position. And it also generates these dynamic shadows, which are very important to distinguish between a bump and in the surface or a cavity. Electronic biopsy is really a cool technique that allows you to look below the surface, behind the surface, and analyze the polyp and get a signature of it, whether it is cancerous or becoming cancerous. The electronic biopsy basically behaves like a flashlight, and the frustum of that flashlight can be changed using the wand touchpad. And what is important about it, unlike the desktop version, that it's view independent. Bookmarks are an extremely useful technique. Basically, the doctor navigates and sees something suspicious, leaves a bookmark there, and it's good for marking an area of interest as well as teleporting to a position later on. And we have a mechanism to distinguish between multiple bookmarks in the same area, as well as what you can see here on the right is a world in miniature of the column, the column overview that I showed, the 3D model of the column that I showed you in the desktop version. And the bookmarks are also placed on that world in miniature. The slice view, we placed these sagittal, coronal, and axial views for the doctors, these 3, but also a 3D model in front of them. Later on, we got feedback from the doctors, and they said, no, we don't need the 3D, just give us 2D, but big ones, large ones, so we can, and that's what we did, and it worked very nicely. The pipeline, I won't go into a lot of details, but we start from DICOM images, we cleanse them, generate a mesh, as well as a center line, and then in runtime, basically the doctors navigate in a rendered and lighted scene. And we have a lot of widgets that we spoke about, which are also integrated into the rendering and the view and the lighting. The interaction is done on a pad, and we have 4 basic modes, which are selected on the pad. Basically, the biopsy in the flashlight mode, the measurement mode, the navigation mode, and the bookmark and slice view mode. This is about the interaction. The rendering, basically, we used accelerated volume rendering by skipping empty space. And that actually works very nicely. I'll show you in a comparison in a minute. And for the illumination, we also use mesh skipping, but we also combine the mesh and volume illumination together. So here you can see on the left, without space skipping, gives us about 80 frames per second. With space skipping, we get about 60 frames per second. And you can see also the illumination works well or better with the space skipping. We use a HTC Vive for that with a wand. And we conducted a long expert study with our radiologists. We have 3 very dedicated radiologists, 2 of them you see in the picture, and they literally love it. And when we asked them, what happened when after an hour or 2 hours you get some headache and nausea? Said, no problem, we take a pill and it's over. So that's kind of the attitude of the doctors. I'm not suggesting that everyone will use that technique. Maybe ginger or ginger candies work a little bit better. Anyway, thank you very much.
Thank you very much for your talk. All right, thank you very much. We have a couple of minutes for questions. If anybody has any questions for Arie about this work, please come up to the microphone.
Hi, Robert Bellman from the University of Amsterdam. Very good work, very nice. Could you say something about the level of preparations for the patient? What is required from the patient to be able to do this?
So the virtual colonoscopy is relatively easy prep. You don't have to drink a gallon of Golightly and sit in the bathroom the whole day. What we have is 3 meals in a box that we give to the patient. These are low residue diet with 3 banana smoothies mixed with barium, and you drink 1 for each of the meals the day before the exam. And typically we do it in the morning after this prep. I did it twice already. You're not hungry. And actually, banana smoothie with barium is pretty tasty.
I was wondering if any of your users experienced motion sickness when you're navigating, and if you've thought about different ways or you tried different ways of mitigating that.
Yes, yeah, they did. And these are relatively young radiologists, below 50 years old, and they love these kind of devices, and they can sustain a little bit of motion sickness and nausea, and they gave me like a list of pills that I can take if I get this kind of nausea, and they know about candies. So this is the solution they use. They said even a green apple can help you too.